Parallel AC circuits. So here we already discussed about the parallel circuit theory, and now go for problems. Now go for problems. See here, problem. See here, example problem. Two circuits. The impedance of which are given. That is Z1 is equal to 10 plus J15 and Z2 is equal to 6 minus J8 ohms are connected in parallel. Z1 and Z2 are connected in parallel. Full stop. If the total current, that means I, supplied is how much? 15 amps. So what is the power taken by each branch? In Z1 branch power and Z2 branch how much power is taken, and also find out the power factor of individual circuits and combination of power factor of these two parallel circuit, and also draw the vector diagram, and also draw the vector diagram. So here Z1 Z2 are connected in parallel, and the total current is given 15 amps. So go for solution. Let I is equal to 15 angle of 0 degrees. That means here the total current is given, that is 15 amps. So angle is take the angle is 0 degrees. Now impedance, the branch 1 impedance is Z1, that is equal to 10 plus J15. Here 10 is the R1 and J15 means L. J15 means here inductive reactance, that is XL. So Z1 is in 10 plus J15, that is in rectangular form. By converting this rectangular form into polar form, so that is 18 angle of 57 degrees. Now branch 2, Z2 impedance, the branch impedance, second branch impedance Z2, that is equal to 6 minus J8. Here this 6 minus J8 is 6 minus J8 is in rectangular form, that equal to converted into polar form 10 angle of minus 53.1 degrees. Here the total impedance both are Z1 Z2 connected in parallel. So the resultant impedance or the total Z is equal to Z1 into Z2 by Z1 plus Z2, that is equal to 10 plus J 15 into 6 minus J8 divided by 16 plus J7. From these values can get the 9.67 minus J 3.6. This is in rectangular form. To convert in the polar form, we'll get the value is 10.3 angle of minus 20 degrees 0.4. So here applied voltage is given by the formula is here V is equal to I into Z. So 15 of angle 0 degrees, that is equal 15 angle of 0 degrees into 10.3 angle of minus 20.4, which gives a 154.4 angle of minus 20.4 degrees. This is the applied voltage across the two branches. So now I1 is equal, formula is V by Z1. This voltage is 154.5 angle of minus 20.4 degrees divided by 18 angle of 57 degrees, which results 8.5 that angle of minus 77.4 degrees. So this is the I1. I1 is 8.58 angle of minus 77.4 degrees. Now I2 is equal to V by Z2, that is equal to V is 154.5 angle of minus 20.4 divided by Z2 is 10 angle of minus 53.1. So which gives I2 is 15.45 angle of 32.7 degrees. So here I is, see here the vector diagram. See is a vector diagram. I is reference as I is taken as reference. So this is an x-axis. So current is, so I2 is leading, I1 is lagging. I1 is in the branch 1, I2 is in the branch 2. So I1 is a lagging current, I2 is a leading current. So here the resultant current I1 and I2 combination, which gives the I. So here the voltage is V is minus 20.4 degrees with respect to the current. Here the voltage is lagging. That means here with respect to the voltage the current is leading. I is leading. How many degrees? 20.4 degrees. So I1 is lagging, I2 is leading. This resultant will give the I and V angle is 20.4. This 20.4 is pi value. So which gives the cos pi value, that is power factor. So this is a vector or phasor diagram from this problem. So now I1 I2 and determined. So now we could also find branch current as under. So that means here another method to determine the I1 and I2. So this is the formula for I1 and I2. Here I1 is I into Z2 by Z1 plus Z2 and I2 is equal to I into Z1 divided by Z1 plus Z2. It is seen from phasor diagram figure 14.9 that I1 lags behind voltage. So here only I1 and V, compare I1 and V only. It's very important note on it. It is compare I1 and V. I1 lags behind V by 77.4 degrees minus this current, and that means 20.4 degrees, which gives 57 degrees. So here the voltage and I1 phase angle is 57 degrees and I2 leads, so it's by 32.7 degrees plus 20.4 degrees, which gives 53.1 degree. So now P1 is equal to I1 square into R1. Here I1 is 8.58, that square into multiply with the resistance R1, that is 10, is gives 736 watts. And also power factor of the branch 1 is, so here V and I1 degrees is 57 degrees, so here cos pi 1 is cos 57 degrees. So this 57 degrees how we will get? So I1 lags behind V, so that means 57 degrees. Here see, observe this one, I1 lags behind V by 77.4 20.4, which gives 57. So that is cos 57. So 0.544 lag. P2 is equal to I2 square R2. So P2 is equal to I2 square R2. So 15.45 whole square into 6, that is equal to, so 1432 watts. So from the branch 2 the power factor is cos pi 2. Cos pi 2 is from the V and I2. V and I. This is, so 30.7 plus 50.4, that is gives the 53.4 53.1 degree. Here power factor 2 in branch 2 Power factor in branch 2 is cos 53.1 degree, that is 0.6 power factor. So combine this power factor, that means the phase angle between the V and I is 20.4. This is the overall phase angle between the current and voltage. The cosine angle between the voltage and current, which gives the overall power factor, that is cos phi. So here the combined power factor is cos 20.4 degrees, that is here 0.937 reading. So now this is what we have calculated or determined from this problem. So they given Z1 and Z2 and the current supplied, total current supplied is 15 amps. From this concept we can calculate. So first of all, all these are in rectangular form, convert into polar form, we get the phase angle also. So now from these values, so we determine the voltage I1, I2 and the phase angle between the V and I1, and in branch 2 V and I2 the phase angle. So here the power taken by the circuit 1, that means branch 1, and the power drawn or taken by the branch 2 P2 has determined, and individual power factor also determined in branch 1 and branch 2, and after that the combined power factor also determined. This is the overall solution of the circuit, solution of the problem. So now go for other problem. So here see, observe this one. Two impedances are given, that is Z1 8 plus j6 ohms, this is in rectangular form, and Z2, that is equal to 3 minus j4. These two impedances are connected in parallel, Z1 Z2 in means Z1 Z2 in parallel. Stop. If the total current of the combination is 25 amps, find the current taken and power consumed by each impedance. The same procedure we are following the circuit here, same. So here Z1 is given, Z1 is equal to 8 plus j6, so it is in rectangular form. So now convert polar form, so will gives the 10 angle of 36.87. Now Z2 is equal to 3 minus j4 is in rectangular form, convert into polar form, which gives the phi angle of minus 53.1 degree. So next one is overall impedance or total impedance, that is Z. These two branches or impedances connected in parallel, so the resultant impedance Z is equal to z1 into z2 by z1 plus z2, that is equal to 10 angle of 36.87 into 5 angle of minus 53.1 divided by 8 plus j6 plus 3 minus j4, that is will give the 50 angle of minus 16.23 divided by 11 plus j2, that is equal to 50 angle of minus 16.23 divided by 11.18 angle of 10.3, that is equal to 4.47 angle of minus 26.53. So here minus 26.53. So now current is given, that is I equal to 25 angle of 0 degrees. So now V is equal to I into Z. Substitute current in this equation. So 25 angle of 0 degrees into 4.47 angle of minus 26.53, that is resultant current, resultant voltage is 111.75 angle of minus 26.53. So now I1 is equal to V by Z1, that is 111.75 angle of minus 26.53 divided by 10 angle of 36.87, that is equal to 11.175 angle of minus 63.4. So now I2 is equal to 111.75 angle of minus 26.53 divided by 5 angle of minus 53.1, that is equal to 22.35 angle of 26.57. So now the phase difference between voltage and current on branch 1 I1 is 63.4 minus 26.53, that is equal to 36.87 with the current lagging. So hence cos pi 1 is cos 36.87, that is equal to 0.8. Now power consumed in branch 1 is P1 is equal to VI1 cos pi 1, that is 11.175 into 111.75 into 0.8, which gives 990 watts. Similarly, pi 2 is equal to 26.57 minus of minus 26.53, that is equal to 53.1. So now in branch 2 the power factor is cos pi 2, that is cos 53.1 degrees, that is equal to 0.6. Now power consumed in Z2 is equal to VA2 cos pi 2. So now here 111.75, that is multiplied with the 22.35 into 0.6, which gives the 1499 watts. This is the problem for I1, I2, pi 1, pi 2 and P1, P2 and cos pi. So now go for another problem. So here the question they has given, refer to the circuit of figure 14.10a and determine the resistance and reactance of the lagging coil, load and the power factor of the combination when the currents are as indicated. Here 14.10 is given. See here, observe this one. Observe this one. Supply voltage is, the supply voltage is 300 volts RMS and the current in the resistance is 2 amps and the current in impedance Z and branch 1 is 4.5 amps and the resultant current is 5.6 amps. See here, observe from this, very important, observe this one. Once again you see, observe this one. Z has not given, only the current 4.5 amps has given and 2 amps is given and resultant 5.6 amps given, 300 volts is given data. So now see here, as seen from the figure 1.14.10b, I1 is the resistance current 2 amps is x-axis and another branch current 4.5 amps is lagging. So that is angle of theta, and this 2 amps and 4.5 amps will result and gives the 5.6. So here AB is 2 amps, so AC is 300 volts, BD is, that means in branch 1 current is 4.5 amps. So AB and BD, which results gives the 5.6 amps, that is AD. So now here BD and BC and CD take, so here see here, observe this one triangle. The current triangle has given, as seen from the triangle ABC figure 1.0b. That is here, what is the formula here? In generally parallelogram method is, so for example parallelogram method is whenever P and Q are in parallel, the parallelogram method is P square plus Q square plus 2PQ cos theta. So that is the formula applied here. So now the resultant current is 5.6, 2 and 4.5 are resultant current in parallelogram method, 2 square plus 4 square. So that means 2 PQ cos theta apply here. So now 5.6 whole square, this resultant current square is equal to 2 square plus 4.5 whole square plus 2 into branch 1 current and into branch 2 current into cos theta, that is 2 into 2 into 4.5 into cos theta. Here cos theta is equal to, from these calculations, cos theta is equal to 0.395. So from cos theta we determined 0.395. Immediately we will get the sin theta. That is sin theta is equal to 0.919. So here what is the Z? Z is equal to voltage by current. So Z is equal to voltage by branch 1 current, that is Z is equal to 300 by 4.5, that is 66.67 ohms. Here R is equal to Z cos theta, that means here Z is 66.67 into cos theta is, here cos theta is 0.919. Cos theta is 0.919. That is 61.3 ohms. Now here power factor is cos pi is nothing but AC by AD. Here AC is 2 amps plus and 4.5 into 0.395 divided by 5.6, which results in 0.67 lakh. It's very important. This is, so cos pi is AC by AD. Cos pi is AC by AD, that is AC is 2 amps. So here BC is nothing but a active component of current. So here 4.5 into 0.395, it is 2 plus 4.5 into 3.395 divided by 5.6 is resultant. So already we learned in the previous class. So here cos pi is active component by resultant current. In generally, active component of current divided by result total current. So that is the formula here applied. So here power factor is 0.67. This is the problem for this circuit. Here solution is, the question is solved.